Howdy AP PreCal, it's Miss Kosh. I think this is video 6 from Unit 1 of Mr. Passwater's multiple choice practice problems. We have been doing some stuff with limits, but this is asked slightly differently. Well, go back and watch the previous 5 videos, especially before you ask me for the PDF. I'm not going to give it to you. You can find it from him. Or anyway, see my comments. Okay, so this one, A and N. Okay, so the polynomial function is given by this, where A and N is greater than. Maybe they mean A and N are real numbers. Anyway, let's see. So we're saying what happens as we go to negative infinity, it goes to positive infinity, so it's coming from up here. As we go to infinity, it goes to negative. Okay, so it's doing something like that. So my A value has to be negative, and my N value has to be odd. So negative and odd, not negative and even, positive and odd, positive. Okay, there we go. So think through that. My sense is that this is not the hardest part of our course, but you just need to read carefully. Okay. These seem to be very similar. Oh, let's jump to 118. Okay, that's something different. Which of the following statements about the end behavior is true? Okay, so here's what I noticed. This polynomial, this is not a polynomial. It's a rational function because it's a polynomial divided by a polynomial. And it's bottom heavy. So that tells us that we have an asymptote of y equals 0. We do have a 0. And we don't have, this one's weird. We don't have any vertical asymptotes because if I set this equal to 0, then I get x squared equals -3, and I'm going to get a non-real answer. So no matter, in other words, no matter what I plug in to this equation, I don't have any domain restrictions. I can never get 0 on the bottom because the only way I could is if I plugged in an imaginary number, in particular, plus or minus I root 3. Okay, but it has this asymptote at y equals 0. We have a 0 though. 2x minus 9 can equal 0 when x add 9 divided by 2 equals 9 halves. And so what this tells us is because it's kind of this weird function, it crosses the asymptote, but then turns around and approaches it. Let's see how hard it would be to type this in and show you what I'm talking about. Let's see, who knows what we were doing last on these calculators? We were doing parametric. Isn't that fun? Okay, let me delete, oh, exit, delete. Okay, so what did we have? We had a numerator of 2x minus 9 and a denominator of x squared plus 3. I'm going to set my window to standard because I think we did crazy things with what we were just doing. Okay, and sure enough. So here's what I was describing. We do pass through this point 4.5. So it's approaching from underneath over here, and then it comes up, crosses the x-axis, and then turns around and comes back to it. So this is a weird sort of rational function, but there you go. Okay, so let's see if we can actually answer the question that they asked. Which of the following statements is true? As the input value of R, I was like, R is not the input value. As the input value of R increases, the output value decreases without bound. No. That gets arbitrarily close to 0 because we knew we had an asymptote at 0. Okay, I talked way more about that one than I needed to. We could get to the answer a little more quickly than I did, but that's great. Okay, number 119. So on this one, it's the same degree, top and bottom, and so we can divide the leading coefficients. So I have an asymptote of y equals 1/2. And so as the input values, the output values get arbitrarily close to 1/2. There we go. Okay, so this one is top heavy, which means it approaches an asymptote. And so we want to look and see, well, what the asymptote would be. What's my best solution for you here? I think since we're dividing by a negative, it may be a negative sloped asymptote. I'm guessing that the asymptote is going to look something like that. So as we go to negative infinity, I think it's going to go to positive. My guess is not this one. My guess is negative infinity, positive. I think it's this. But you know what? Just for grins, I'm going to divide so that we have, I'm doing synthetic division, which isn't actually part of our course, but it is. Oh, no, I can't do it. Y'all, this is annoying. Do you know what? When all else fails. Let's see if my reasoning was sound. It may or may not be. It could go either way. What am I doing? I think I'm funny. I hope somebody else does too. But you know what? They pay me the same either way. That's what I tell the kids. They can do their homework or not. They pay me the same either way. Okay, so as I'm very distracted here and typing this in, we're looking at something like this. Whoa, what is happening? Okay, so it looks to me like we're approaching a kind of a weird sort of asymptote. Let's zoom. Let's change our window to go. I think our x's are fine. Let's go more negative in our y's and more positive. Let's change our y's a little bit. Okay, it does appear to have that, my reasoning was sound, that if we've got this asymptote, it's kind of something weird, and it's not really connected here. There's asymptotes through the middle, and it's all sorts of, Desmos would be better. If you're really curious, go look at Desmos, but I was right on that one. Okay, which of the following describes the end behavior? So when we rewrite this, this is 2x cubed minus 9 over negative x cubed plus 4. Divide our leading coefficients, we're at negative 2. So we're going to approach, we were the same degree. So as we go both to negative infinity and positive infinity, we approach negative 2. Okay. Let's look at this next one. And this is top heavy, so we would, it's going to approach an asymptote. The slope of the asymptote is, since they're only 1 degree apart, the asymptote is going to be a slant, so it's going to be a line. This one, they were not 1 degree apart, they were 3 degrees apart, so it was actually approaching this weird cubic thing. Okay, so I should not have drawn a line here. Yeah, that's an ugly problem. Okay, this one though, only 1 degree apart, and I think the if we did the division, the very first thing, we would have a line with a slope of 1. And, okay, so what does it say? Since the polynomial in the numerator dominates the polynomial in the denominator, has the end behavior as of x equals, oh, yeah, okay. And as it goes to negative infinity, it's going to go to negative infinity. I don't see how, okay, this one is definitely wrong because of slope. If we do have this line, y equals x, then it's gonna go something like this. So as we go negative, we'll go negative. So this can't be right. Negative, how is that different? Since the denominator, no, it was the numerator was dominating. So that's what, so our answer choice is A. These are good, you guys. Okay, let's see. Oh, here's another, I'm telling you, AP PreCal, they really like their inequalities. I have done more inequalities this year than ever. Okay, so what we want to do with this one is we want to include our zeros and our asymptotes, and so I cannot let x equal positive 3, so sometimes I make this one a dotted line so that I know it can't equal that, but we could x equals negative 2. Actually, I don't need it to be dotted or not, because since it's less than, or this is a greater than sign, but since it's not equal was my point, then I won't be equal to any of these things. Okay, so let's see. If I plug in 0, then these are gone, and I'm left with a negative 2/3. So is negative 2/3 greater than 0? No. Negative 2/3 would be negative here. Plug in a 4, I get a positive over a positive is a positive. Plug in a negative 3, and I get a negative over a negative is a positive. So where is it going to be greater than 0? Where is it positive? So from negative infinity to negative 2, and from 3 to infinity. Very good, very good. Okay, oh my. Where is it greater than or equal to 0? So what do we need to consider? We need to consider our zeros. So I need to consider 3 and negative 2 and positive 5. So here's negative 2. Oh, we do want to consider so on this one they changed it from greater than to greater than or equal to. And so here comes 3. We can equal 3. We can equal negative 2. We cannot equal positive 5. That was what did I say? 3. Okay. So where are the intervals where this is going to be? So let's plug in 0. That gives me a negative times, if I plug in 0, this gives me a negative squared as a positive. So a negative times a positive divided by a negative. I think I had one negative here and one negative there, and those two are positive. That's going to be a positive. Okay. Plug in 4. I have a positive. Squared is still positive. I have a positive, I have a negative, and I have a negative. That's still positive. And think about it. The squared means it bounces. Sure enough. Plug in a 6. I have a negative times a positive, times a positive, times a positive. So this is going to be negative. Plug in -3. I have a negative, but then I square it, so it's positive. Oh, but there's a negative here. Negative, positive, negative. You guys, I lost track. Okay, I have a negative, and then I have a negative, but I square it, it becomes positive. And then I'm plugging in -3, that makes that negative, and then this is going to be negative. That's 3 negative, so that's negative. So where am I greater than or equal to 0 from -2 to 5? I can include, oh, good job. I can include -2. I cannot include 5. So there is that answer. What are the zeros? My zeros are 0, 2, and 3. 0, 2 only? Nope, 0, 2, and 3. Oh, no! I guess who needs to pay attention? I'm so sorry. We have holes. We have lots of holes. And so that changes things. So if we cancel, this is going to look like, it's going to look like r of x is equal, well, it's going to look like the equation y equals, we're going to have an x that's left on top. We're going to have an x minus 2, and we're going to have on the bottom, 2 of these will cancel, we're going to have an x minus 3. It's going to look like this equation, but it's going to have a hole at, it's going to have a hole when x equals 0, which is going to be, when I plug in 0, I think I do get 0 because there's a x 0, that's going to make this whole thing go to 0. We're going to have a hole at 3, oh, nope, we're not having a hole there. That's now an asymptote. There's an asymptote at x equals 3. And so where are my zeros? Well, this is a hole, so it's not a 0. And this is a asymptote, so it's not a 0. So my bad. Did you catch that? I almost made a mistake. So I think this is A. That's fun. Okay. We'll make this the last one for this video. It has a 0 at x equals -3. So x plus 3 has to be in the numerator. And it has a 0 at x minus 4. Which of the following? Okay, so we can divide by x minus 3. That's fine. This A is fine. We have weird asymptotes, but that's fine. What about this one? We don't have a 0 at, this one has an asymptote at -3, but not a 0, so that's no good. This one has a 0 at 3, and okay, this would, the reason C doesn't work is because these things right here, x equals 4 becomes a hole, and not a 0. And this is it should be x minus 4, but the same thing holds true with the zeros. That A is our answer choice, or is our best answer. All right, how much more do I have in, oh, y'all, he's done good work. Oh my goodness, this is a little overwhelming. Okay. Oh, okay. We'll have a few more videos probably. All right, come back and see me. Subscribe, like, comment, post, share this with your friends so that we all do really well on this test. All right, good luck. Go practice.